Okay, this is the planting crop acreage. A farmer in the business of growing fodder for livestock has 90 acres available for planting alfalfa and corn. So this first sentence gives you the first constraint. So let's make our variables alfalfa and corn. So X is alfalfa and Y is corn. And we're talking about acres of land for growing stuff. All right. So the first constraint is X plus Y has to be less than or equal to 90. By the way, if you start a problem like this and it turns out you were wrong, at least you had something to begin with, right? So don't be afraid to just start writing stuff down. Most of the time, people don't do word problems because they're afraid to start it. You just write stuff down. You're allowed to go back and change your mind. Okay? All right, the cost of seed per acre is $4 for alfalfa, so that's 4X, and $6 for corn, so that's 6Y. That was seed. Is there anywhere else that has seed? Down here, right? It's 480. Oh, so you can have only up to 480. Okay, so we use the $4 for alfalfa, $6 for corn. Labor, now we're looking at labor. $20 for alfalfa and $10 for corn. And labor again, $1,400. Okay. Then we have this information, the expected income. So income is when you're making money, right? Income from alfalfa is 110 per acre and 150 per acre. And then I go on. So let's say you weren't paying attention, you just wrote it down here, 110 and 150 per acre. And you're looking for other information. There is no other information. In fact, it's asking you to maximize the profit. So that means it turns out that this does not belong with the constraints. This is the objective function. So don't put it down there. Put it up there with the objective function. So don't be afraid to just write down these combinations. Okay? And then you're allowed to weed it out. Oh, that doesn't belong with the constraints. It's the objective function. It's easier to just write this down and then delete stuff than it is to not do it at all. Okay? Alright, so now I'm going to take time to write these equations, solve for y. So here's x plus y less than or equal to 90. That becomes y is less than or equal to negative x plus 90. Right? All I did was move the x from the left to the right. And then we have 4x plus 6y. That one's going to take a little more effort. So that's going to be 6y is less than or equal to negative 4x plus 480. So all I've done so far is move the 4x from the left to the right. You change the signs when you do that. Now I divide by 6. So give me y is less than or equal to negative 2/3 x plus 80. Alright, so we got 1, 2, and the last one. 20x plus 10y is less than or equal to 1,400. So that's going to be 10y is less than or equal to negative 20x plus 1,400. Alright, let's divide by 10. So that's negative 2x plus 140. There's our third equation. Third inequality. Alright, now let's graph these things. We need up to, let's count by tens. So we're going to go up to 14. So we need about half the paper. Probably not that much. Oops. Okay. So the first one was y is less than or equal to x plus 90. So that means I start at 9. I have have a slope of 1, so we'll or -1 rather. Next one is 2/3 x, -2/3 x plus 80. Let me connect these first. 80 is here. -2/3 down 2/3. So it hits there. Down 2/3. Down 2/3. And then the last one, it starts at 14, but has a slope of -2. That was 9, 10, 11, 12, 13, 14. Slope of -2. And all of these were less than lines, right? All of these were less than inequalities. So this is the shaded region. Remember, all of these assume that you have to be positive, so I don't have to shade below the x or y axis. So I have 1, 2, 3, 4, well, technically 5, the 0, 0. So this one up here was 0.8 or 80. And this one here is 3, 1, 2, 3, 4, 5, 6. 30, 60. This one here is 1, 2, 3, 4, 5, 50. 1, 2, 3, 4, 40. And the last one here is 1, 2, 3, 4, 5, 6, 7. 70, 0. Okay. So we take these ordered pairs, plug them in. My function was p of xy, which is 110x plus 150y. Remember, that's our objective function. Plug them in. So let's start with 0.80. 110 times 0 plus 150 times 80. Pull out the calculator. Pull out a working calculator. And I got 12,000. 12,000 in profit. And then, what was the next one? 3060. 110 times 30. 150 times 60. And I got 12,300. And 5040. And 11,500. And the last one, $110 times 7. I got 7,100. Okay, so the biggest profit is 12,300. So 30 of alfalfa and 60 of corn. So you do 30 acres of alfalfa and 60 acres of corn for 12,300. Or at least income. Anybody else want to do one of these? Matt, you want to do it? Yeah. Come up here and do it. Isn't it boring to listen to me all the time? Yes. Oh, anybody still need that? We're good? We're good? Alright. Production scheduling. Profit of 15 on oversized rackets. So let's make oversized rackets. Oversized rackets X and regular rackets or standard rackets Y. It says profit. Let's see if that's what we're looking for. Profit. So we can start with the objective function. 15x plus 8y, and that's our objective function. So P of xy. To meet dealer demand, daily production of the standard rackets, so that's y. So that's going to be, what's that, 30 to 80 for y. And 10 to 30 for x. Right, that's what that means. Production of oversized rackets should be between 10 and 30. To maintain the quality, you can't make more than 80 a day. So that's the two together, you can't make more than 80. I think that's it. So, I don't need to rewrite these two. I only need to rewrite that one, and I can do that right here, right? That one just y is less than or equal to negative x plus 80. So I'm ready to graph it already. Please control your enthusiasm. All right. Don't need that much space. All right, so we have a horizontal constraint of 30 and 80. So let's go by ones here, or tens here. It's 10, 20, 30. So here's 30, 40, 50, 60, 70, 80. All right, so there's 80. So they're horizontal constraints. All right. So it's between those two, right? We're going to shade between those two. And then we've got the other one, the vertical one's 10 to 30. 10 and 30. 1, 2, 3, 30. Really small. Okay. And then we have this thing. The y is less than or equal to negative x plus 80. So that means it starts here and I have a slope of 1, negative 1 rather. Goes to there. Alright, so it was in here. So this is my answer region. So let's look at these coordinates. So this one here is 30, comma, 30, 40, 50. So it's 30, 50. Down here is 30, 30. Over here is 1030. And up there is 1070. Okay. So you're only counting the intersections around the shaded region. If you're having some difficulty with what should be shaded, please ask me. It seems like most people are getting the shaded part right. Most confusion lies in which vertices do you look at. You only look at the vertices around the shaded region. Alright, let's test those out. Got plenty of space here. So we're looking at the profit of 10 and 70 rackets, or 10 and 30 rackets, 30 and 30 rackets, and 30 and 50 rackets. So what does 1070 look like? The function was 15x plus 8y. So that's 15 times 10 plus 8 times 70. So that is what? 710? 15 times 10 plus 8 times 30. So this is obviously less than that, isn't it? And this one, 15 times 30 plus 8 times 30. And that's 690. And the last one, and I got 850. So, profit for a profit of $850, make 30 oversized rackets. Oversized. And 50 standard. Are we doing any better? Huh? Please control your enthusiasm. Alright, let's stop the recording before I say anything more stupid.